Hello everybody. For my assignment this week, I'm going to be focusing on the accessibility of this worksheet that I created for a lab that we were doing in my science class. Just a little bit of a reminder about myself. I am a 5th and 6th grade teacher at a magnet school in Harrisburg City. I teach in a brick and mortar school, so all of these worksheets that I have would traditionally be printed for the students to write on directly. So, for this lab, I feel like it's easiest to explain it in the context of the entire lesson, because one worksheet really is not a snapshot of the whole lesson. So, to start off with, my lab was on physical and chemical change, which is following the standard of having students being able to differentiate between physical and chemical changes and the properties that go into these changes. To start off, we had the students answer a couple questions to access their prior knowledge about physical changes, chemical changes, and the law of conservation of mass. Following this, I split students into groups. They were intentionally grouped so that students had somebody that they were able to work with. For the students, the way the room was set up was I had 14 different stages around the room where they had different activities that the students were going to participate in. Each one of them had a station card at it telling them the procedure. While the lab was taking place, they made observations about what was happening during the lab, and based on the observations that they made, they figured out if it was a physical or chemical change and why they believed that. They had to use the knowledge that they gained from previous activities. After they finished all of the stations, I stand corrected, it was 13 stations, not 14. They had a couple follow-up questions. Some of the questions they could answer before. Some questions they needed to do while they were at stations, like these two, where they were actually seeing about the change in mass in a closed system versus an open system. So number 2 was talking about an open system, so they were tracking it as it went through certain time periods. And in the closed system, they measured the mass at the beginning and the mass at the end and took note of what happened and why they were different. There were just a couple more questions and then some bonus questions, which is on content that we hadn't quite covered, but is something they'll be covering in a later grade about balancing equations. After they finished this entire lab, they went and they made groups of their own where they needed to create a final artifact, which helped them to explain to other people that were not there present for the labs what exactly physical and chemical changes are. I left it very open for the student to pick whatever they felt would be best to describe it, including music. A lot of my kids like to rap, video or film, creating a scratch presentation, creating a poster, writing a story, anything that they could use to kind of show that they learned what physical and chemical changes were. So, on top of that, I'm going to quickly pull this up. Let it load for a second. Not sure if that worked. I'm just going to exit. Okay, so just so you can see this, for my final calculations here, I started with the UDL standards, Universal Design for Learning. I know it's hard to see, but I'm afraid that if I press present that it's not going to show up because I'm on a different computer because my first computer didn't work. I'll link my presentation in a format that you can go in and read a little bit closer. So first thing, in the engagement section, I boxed the optimizing individual choice and autonomy, and the optimizing relevance and value, because in my lab, students were able to choose what they wanted to do and how they wanted to present their content at the end, and that created relevance to themselves. It allowed them to connect to their own world and allowed them to draw connections with other people's worlds as well. Following that straight down, it also helped to increase mastery-oriented feedback, meaning that I wasn't giving them a strict, here's A, here's B, here's C, find the answer. I was having them actually show me that they had mastered the content by applying it to other content areas. Representation, I found different ways of customizing the display of information. I had the boxes which allowed them to organize it that way, but when it came to the final project, they were able to display the information in any way that they saw fit, whether it were visual, auditory, or I even had some students create like cut and sort like panelings that they used to describe it. Following that straight down, I activated prior knowledge for the students by basically having them answer those pre-lab questions and we discussed a little bit before we began. I had them highlight patterns by having them kind of analyze what they had learned about before and going through and saying, oh, well, since this exhibited this trait, this exhibited this trait, this exhibited this trait, and all of these traits are chemical properties, they must be a chemical change that have occurred. And finally, this was transferring the knowledge because it allowed students to kind of take the knowledge that they've learned and apply it through their final expression. I built fluencies and supported practice and performance by allowing students to kind of take it and run. And finally, with the executive functioning, I actually specifically planned this lesson around having students express what they had learned and allowed them to create their timeline. I set a final date. All of this work was done within a 5-day period where students did the testing for 3 days. Then they had 2 days to plan their final activity. So students decided on the first day what they needed to accomplish, and then Friday what they would be able to accomplish. Some students who were more ambitious had to come in before school and came to our advisory period where they had access to the computers and to filming equipment, iPads, green screens, whatever they needed to actually accomplish their filming. For my Word documents, I found mine specifically would need a lot of work to make it accessible in an online classroom. Because it was a physical handout, they would not normally be reading a text reader, and because of that, I've honestly never thought about making the headings so that I can easily use this in an online setting. So I did not format any headings. The alt text feature I found was incredibly interesting, especially after watching the video of how the text reader reads those pages. I hope to actually use that later when I create more because it's a great review tool even if the student doesn't need those tools. It's a great way to go back in and review because it provides what exactly I said about the image to the students that may not have been there for that lesson. I didn't have any lists or links or math and science that needed to be put into the Word document, so those ones did not apply. My tables. The way the text reader in the video was describing how to make the tables was really interesting to me, but I feel like it partially takes away from the usability of the tables when it comes to a science data collection tool. If I were creating a table that students were purely reading off of, yes, I would change it, but I don't think I would change my tables for data collection. That's just my opinion there. But I don't know about the reading order. I would have to go back in and check the reading order. For color, I didn't use any color because we only have black and white printers at my school, so using color was not worth it for me. So I followed those rules by having sufficient color contrast and having the color not conveying the meaning, but sometimes I would bold things that would allow meaning to be conveyed. And I did not use forms. Okay, principle one. I used pre-teaching and prior knowledge. I used multiple examples and non-examples by showing different kinds of physical properties and different kinds of chemical properties that indicated the changes. I used outlines and graphic organizers, or the kids did, to help them express themselves. And I provided multiple flexible paths at the end by allowing them to choose how they wanted to do their final project. Use of interactive simulations. It's really hard not to use interactive simulations when you're in science class, so I always incorporate that. For Principle 2, I provided opportunities to compose in text, speech, illustration, film, or music by allowing students to choose how they made their final artifact. I used guides to provide support and promote autonomy. Used guided questions for self-monitoring, and used self-explanation and self-assessment. When I provided students with their timeline, I sat with them, the students that needed my help, and helped them plan out on day one. We're going to make a list of how we're going to do this. We're going to make a script. On day two, we're going to use the iPad. We're going to film our skit and edit it in the second half of class. So they had a planned list of what they needed to do. Other students kind of made their own timeline that allowed them to kind of create on their schedule. Guided questions and self-monitoring. Students were required to show what they had kind of accomplished for a day. They needed to kind of put in a worksheet, is what I called it to me, to show what they had accomplished and what they needed to accomplish the next day, what the first step was, what the second step was. Self-explanation and self-assessment. Before students turned in their final projects, I gave them a rubric of what I was expecting to see in that final project and really had the students grade themselves. What did I do well? What do I need to work on? And I allowed them time to go back and change those things they needed to work on. Finally, third principle. I allowed student choice in challenges. They were able to choose how they were going to show their answers. I personalized the learning to their lives and interests by allowing them to choose what they did. My students that are constantly writing raps were able to write a rap that was content related. I encouraged active participation, exploration, experimentation because it was a science class. They were conducting science experiments. And finally, I provided opportunities for collaboration in every step of the way. Collaboration between students when they were discussing what they saw, what the outcomes and observations they made, and what those observations meant as a whole. I also provided opportunities for collaboration, not just with the students that they were working on during the lab, but they were able to separate and choose new partners and kind of work with those people that were able to help them. So students that wanted to create a film project, who likes to film, who likes to be on camera, who likes to do the editing. Students who are making raps, who wants to write the lyrics, who actually wants to perform, who wants to provide the backbeat. Students who created posters, who likes to do the lettering, who likes to find the content, who likes to draw the pictures. Those kinds of things provided students the opportunities to work together and showcase their own skills. Thank you.